Okay, good morning. Good morning, everyone. Good morning. We thank you and welcome to our lectures for today. We will wait for about 5 minutes to have a majority of you join. And once we have a majority of you, I think we should begin with about 30. Should expect somewhere between 100 and I think 120 or so. So just give me a few minutes, then we can begin. Okay.
Okay, sir.
Okay, sir.
Okay, good morning again. I think we can begin our lecture this morning. Okay. So today's lecture outline, what we'll be looking at is firstly, we will look at control structures. We have mentioned this in our subsequent lecture. And basically what control structures are, we will look at different kinds of control structures and programming language statements that qualify as control structures, okay? So we'll look at sequential control structures. We'll also look at decision control structures and look at loop control structures, what they are. These are basically the primitives of programming languages. Then we will start and take a good look at decision control structure and what it is. We'll look at the various forms of decision control structure and how they can be written in various programming languages. So basically, when we say structured programming, like our second class or our first class in the discussion, we said in programming, there are several ways we can do programming, just like letter writing, okay? And what structured programming is that structured programming is a programming paradigm. Basically, what it details is that you want to write programs where you design the program systematically. When we say a program is designed systematically, what we mean is that the program is designed so that the steps are organized, step by step manner, okay? When we say organized, we simply mean step by step, okay? We systematically write the code to be step by step. We go from 1, then we go to 2, then we go to 3, then we go to 4. The structure is in a logical way, okay? Now, computer programs, we can write in many different ways, but this is perhaps one of the easiest way to begin programming. That is why we adopt it as a programming paradigm, and especially for your class. Now, most programming languages support structured programming, and so it's also one of the key reasons why it is chosen or is being used in your class. Are we okay? Now, there are many different control structures in various programming languages, but in general, there are 3 main ways to write computer programs, okay? Or 3 main control structures that computer programs come in, okay? Okay, now, for computer programming or control structures can be written as sequential. When we say sequential, they can also be referred to as sequence control structures, okay? These ones are code which are written line by line and executed from top down manner. And then we have code written as what? Decision. Decision over here, we simply refer to code where a decision is being made or a selection has to be made between 2 or more options, okay? So if we have just one option, then we don't need to make any decision, okay? Then we simply go with sequential control statements. But if we have 2 or more options, then we need to make a decision on something. And if a condition is true, we execute a particular thread. Then computer programs where we repeat some actions for some number of times are referred to as repetition or loop control structures. Okay. Now let's take a critical look at sequential control structures. Okay. So what do we mean by sequential control structures? Sequential control structures is basically a type of control structure, okay, where the code is written line by line or one after the other. Okay, so for example, if we are asked to write a program to print the user's name, certainly what we might do is to first start the program. Then we might want to print the user's name, okay? So let's say we are printing my name. Then we might want to end the program. This is line 1, this is line 2, and then that is line 3. Notice that the line or the start of the program is just one statement. Then before we follow it with what? A print, and then we follow it with what? An end. Now, these statements are written from top down and they follow one after the other. An example, or this example, is a classical example of sequential or sequence statements. They execute one after the other in that manner. Okay. Now, the first action is performed. We start the program. Second action is performed. Third action, fourth action, and then on and on in that order. The sequence in a sequence control statements or structure can contain any number of sequence. Okay, but there is no branch. If there is a branch or if there's a decision, then that part of the program is not part of the sequential or is not a sequential control statement, okay? So code where we are doing one thing after the other is what we refer to as sequential control statement. You can see from the example over here that we do the yellow one, then we do the red one, then we do the green one afterwards, okay? Then we have another kind of control statements or other kinds of control statements where we do what we call a branch. When we say we do what we call a branch, what we simply mean is that this structure, we ask a question, okay? We usually ask a question. Then depending on the answer to the question, we normally take one of two or more actions, okay? So for example, we ask if today is Saturday, then the decision will be to what? To join class, okay? So, and if statement. Now, this simple example I've written over here is just a simple demonstration of what an if statement or what a selection control statement might look like, but it's not generally how we write it, okay? There are rules to how we can write it. But if you look at it critically, you can see that we are making a decision based on whether the answer to this question is true or false, okay? So here, the condition, as we call it in sequential control statements, checks. And then if the answer to the condition is true, we run one of these, okay? But if the answer to the condition is false, we run the other one, okay? So a selection control statement can look somewhat like this in flowchart. In flowchart, when we get to the kite, we check the condition. If the condition is true, we pass here and we go and do this one, and then we come all the way down here. But if the condition is not true, then we pass here, we go and do this one, and then we come all the way down there. Notice that there is no way that a condition can be true and false at the same time. It can only be true or only be false, depending on what the test condition actually is, okay? If there are any questions or any issues, kindly draw my attention so I can address them. You can send a chat or you can just put up your hand. When we are done with one section, we will allow you to speak, okay? Can you all hear me, please?
Yes, sir, we can hear you.
Okay,
Okay. Yes, sir. Yes, sir. Yes, sir.
Yeah, we can hear you.
Okay. So a typical example of some of these selection control statements are the if statements, okay? So we have the if statements, okay? We have the if else statement. We have the if else if statement. We have something called the switch case. Okay. So these are all examples of selection or decision control statements. And we are going to, in this course, look at all of these examples and then write code which reflects all of these examples as well. Then the, okay, so I've already explained that for a selection control statement, you have to either be true or false, okay? So let's go on. Now, let's see some examples of selection control statements, okay? So for example, we have this general format, okay? The first example over here describes the general format for a select or a selection statement, okay? You can see that in this general format, we are checking if some condition is true. If something is true, then we do this block of code. Then we have what we call the dual alternative or the if-else statement. Here, we are checking if something is true. If it is true, then we do this one. But if it is not true, then we do the other one, okay? So you can see that there is one for true, there's one for false. Here, there's only one for true, okay? So you use this one if you only want to do something when it is true, and then you use the second one if you only want to do something when it is what? True and or false, okay? Then here, we call it the multiple alternative, okay, or the if-else-if statement. Here, what happens is that we check if a condition is true. If that condition is true, then we do this block, okay? We only do this block if condition 1 is true, okay? Then we check another condition. You can see the if over here. So we are checking another condition. If this condition is true, then we do this one too as well. So true for condition 2. Then we check another condition. If this condition is true, then we do. So we can add as many conditions as we want. Then you can see that at the tail end, there is something called an else clause. So if none of these are true, then we do what we call the else, the else block. The else block is run when the entire thing is false. Okay, so I'll come and explain what or how the mechanism works. We'll do some examples so that you can understand very well how the mechanism of the if-else-if also works. But for now, understand that there are 3 main types of selection control statements. We have the single alternative, we have the dual alternative, we have the multiple alternative. So this is what we will be normally doing in our exams, okay, and in our class exercises and the rest. Now let me show you how the flow chart may look like. Okay, I think, okay. So let's go back to Zoom and then let me show you something, okay. Okay. So in the selection control statements, what normally happens or what can happen is that we can have a case. Oh, my dear friend, stop writing. Hey, Joe Fred, stop that. Okay, so we can have a case where we have what we call the single alternative, okay, the if statement, okay. So for the if statement, we want to check if a particular condition is true. Then what we want to do is that we want to do the statements below. Okay. Then you end the if. Okay. So we can look at this as the syntax. Okay. Something like this as a syntax. Now, what the flow chart will be is that okay. Those of you who are writing on my whiteboard, please stop. Please stop. Okay. 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 So this one, what it will be is that there will be a kite, okay, which is a decision. We are testing if the condition is true. If the condition is true, then we will be doing some statements. And then we will continue with the rest of the code. This is only done if it is true. But if it is not true, which is when the answer is no, we will just continue and run something down here, okay? So, and okay. So you have something looking like this, okay? An infrastructure looking like this for the single if statements, okay? Then the case where we have, oh, don't worry about the writing. Do you want to copy I'm not sure. I'm just going to show you how it looks like, okay? That's all. Don't worry about the writing, okay? Then number 2, okay? Number 2, where we want to do what we call the if-else statement. Okay, here we want to do if, then we have the test is true. Then this is the test, okay? Then what we want to check is that if it is true, then we want to do something, okay? Statement 1, else, do. Statement 2. Then we end the if. Okay, so this is also another kind of if statement. And here, the rationale here is that you have a check. You want to check if the test is true. Then you want to do something if it is true. And then you want to do something else if it is not true. Okay, so let's go down here. Let's do statements. Okay. Let's just make it a process, okay? And then here, we bundle it up. Okay, so you can see that for the if statement, this is normally called the if else statement, okay? So when the statement is true, okay, when the statement is true, when the statement is true, we will normally will pass here, okay? And we'll do this. But when the statement is not true, we'll normally will pass here and then we'll do this, okay? So there are 2 sides to this one as well, okay? Then we have the third one, okay? We have the third one in the row. So you can see the single if statement. You can see the if else statement. And then the last but not the least is the third one. We refer to this third one as if else if. Let me expand a bit. It's called the if else if statement, okay? And in the if else if statement, what's happening is that is there a question? Okay, no question. Okay. So for the if else if statement, an example is what I gave, for example, earlier. So we testing if test or the first test is true, okay? Then what we want to do is do statement 1. Let me just call it simply statement 1, okay? But if it is not true, then instead of doing an else and stopping, we do an else if, and then we have a second test, test 2. If that one is true, then we do statement 2. If that one too is not true, else if, then we do test 3 equal to true. Then we do statement 3. Then we can continue as long as we want, as many of them as we want. Then finally, or optionally, we can add maybe statement n, okay? So this will be in a list of long statements describing how or showing us what the code should do, okay? So here, let me just box this up, okay, like that. So that is an example of an if-else-if statement, okay? We have different tests. We have test 1, we have test 2, we have test 3, we can have test 4, we can have test 5, 6, 7, as many of them as we want. Then optionally, we can have this one, okay? This is optional. So I'm going to put dash around it. So, and I'm going to say that this is optional. You can decide to add this or not, okay? I'll explain how it works. So this one, oh, those of you who are writing on the whiteboard, you should stop doing that, okay? Stop doing that. I don't know why you are doing that. We are learning from the whiteboard, okay? I'm unable to delete it. Okay. And find a tool to delete it. Okay. Okay. So I want to write it up for us. So basically, what will be is that it will be check. Okay. So we'll do if test 1. Then what will happen is that if it is true, we'll have statement 1. Okay. Then if it is not true, then we'll go and do another check. Okay. If test 2 is equal to true, then we'll have statement 2. Then if it is not true, we'll have another check. Okay. Oh, let me undo that. Also, let's undo. Okay, so if test 3 equal to true, then we do yes, and then we do no, and then we do statements. Statements 3. And then we can continue on until we get to the else statement, okay? And then you can see that we will end over here like that. Okay? So if you look at it closely, oh, sorry, wow, sorry, it's turned around. I'm right-handed. I think I'm writing the way my hand is turned. So sorry, okay. But basically that's the general overview. We'll take our time and we'll go through. I can see some comments in the chat. We'll take our time and then we'll go through. Okay, so don't worry about it. I just want you to see how they all look like, or what the key differences between them are, okay? For now, I hope you can see the key differences between them, right? Hello?
Yes, sir.
Yes, sir.
I hope you can see the key differences between them. So you can see that the first one is much more simpler, whereas the second one adds up second layer. And the third one, you can add up multiple layers. Okay. Is it? Okay. Okay, that's fine. Mr. Otabil, Kumi.
Yes, sir. Sir, good morning.
Yes. Morning,
Yes,
sir.
Sir, please, can you go over the if statements again?
Oh, like I said, I'm going to take my time and then we're going to walk through all of them one by one, step by step. Okay.
All right.
I want you to contrast the three of them and see how different they are in terms of their appearance in the flow charts. That's why I had all three of them drawn. Okay. The student who is writing on the whiteboard, I don't know why you are writing on the whiteboard and canceling the things we are doing. Okay. Any other question? Okay, let's go back to the presentation and I'll explain some key things. Okay. Mr. Sam.
Yeah, good morning, Chief. So I think that the slide what you're writing is very tiny, you couldn't see. And so in an attempt to zoom the screen, that's how come it looks like we are writing on it. Very apologies for that.
Okay. Okay. Noted. Okay, noted, okay. Yes, I can't pronounce that. What is that the character? I can't pronounce that thing. Yes, please, you can talk. Hello, the person with the strange name. Okay, he's not talking, so let's continue. Okay, so I just wanted you to see how different the three of them are. The first one was 1, second one was 2, and then the third one is what we saw later on, okay? Now, here are some simple examples, okay? So the situation we can use a single if statement is when we are asking, is when we are asking a question like, for example, if it is raining. So you see, this can have a true or false response, okay? And depending on whether it is true, if it is true, then we come and do this one, okay? That's how the single if statement works. Then in this second example, we are checking if the traffic light is red. If the traffic light is red, remember the cars have stopped, and so it means you can cross the road. Okay, so here too, we are checking whether it is true or it is false. If it is true, then the cars have stopped and you can cross the road. But if it is not true, then do not cross the road. So we notice that the else means false. Okay, in the programming, that's what it tells the computer that, oh, if it is true, do the first one. But if it is not true, then do the second one. Okay. Then last but not the least is a check whether the hours a worker works is over 40 or above. We told that this is a container or a variable. Okay. So this one contains a particular value. Depending on the value, if it is true or false, okay? Remember, this selection only work with true or false. So if it is true, then we come and do these two things, okay? Because these two things are inside the true part, okay? But if it is not true, then come and do just this one down here, which is inside the false part, okay? So that's for false. Is that so? Nathaniel, okay, Nathaniel.
Sir, good morning.
Morning, Nathaniel.
Please, can we get a typical example of this programming in play? Maybe in something we use domestically, maybe an app on phone or some app on our.
We are talking about programming constructs. So you cannot build a whole app and you only have if in there. It's not possible. You use these constructs to build and other things. An app can have thousands of lines of code. Okay, so amongst those thousands of lines of code, which you consider as domestic or whatever it is, there will be some if statements in there. There will be some if-else statements in there. There will be some switch case statements in there. But there's no app in the world which has only an if statement, whether it is domestic or international.
But sir, what I'm saying is an example of maybe, but I know this one, it needs somebody to enter something, a user to enter something before it gives it processes their data back to the user.
Yes, if statements will always check whether the contents of a variable or a value is true or false. So of course you need some data, and you are saying domestic, and that's why I'm saying that you cannot build an app with only an if statement. It's not possible. An app is made up of thousands of lines of code. So it's not possible to just use only an if statement to build the whole app.
So what I want to know is like the way if you are logging into Facebook, they request for maybe your age, your date of birth. I'm asking if this is what they are talking about. This is what.
So the verification check, the part
Yes.
of the Facebook, maybe what you call username verification or password verification.
Yeah.
There will be a part of it that uses an if statement to check whether the password you currently hold is the same as the password you have entered.
Okay. All right. Yeah.
So there will be an if statement over there to check. But there will be also other things to make sure that that thing works. So it cannot be used. It cannot be used wholly to just build a whole program. No, it's just a construct.
All right, sir.
Okay, Mr. Daniel. Mr. Daniel. Okay. There is a question by Daniel. He says, sir, with the first example, does it mean when the statement is false, we will negate the output? No. You are talking about the one with the umbrella, right? Are you talking about this one? Okay, so this one, this type, they only do something when the statement is true. They don't do anything when the statement is false. Okay, so they only do something. We have a situation where we only want to do something when it is true. Okay, so when you want to do something like that, then you use the first example. Are you okay? Okay, he's not signaled yet. Okay. So let's continue. Then the other kind of constructs you will normally also find in programming languages are called, or is the loop or the repetition control statement. So Someone says repeat, I believe most of us already understand the word repeat. And what it simply means is that there is a statement, or there are some statements which allow you to repeat some code or to repeat some actions for some number of times. Okay, so if you want to do that, instead of just rewriting or recopying that code many times, you can simply use those blocks of code instead to repeat that action for the number of times, okay, or that instruction for the number of times, okay. Now, we can do the repeat as long as a given condition is true or false. So here too, we'll have to determine whether something is true or false, and based on the response, whether the thing is true or false, we will repeat the action. Okay. Now let's see an example of how it looks like. So we will see that a typical example is given here in the while. Okay, in programming languages normally have this while loop statement, and we call it a loop because it will repeat this thing for as long as the test condition is what? Is true. So long as the test condition is true, we will keep repeating this. So we'll repeat, we'll come back, repeat, test, come back, repeat. So the cycle will be that if we come here, we will check, is it true? If it is true, you go and do this, you come back to the same place. Then you go and do a second time. You go and do this, you come back to the same place. Then you go and do a third time. You go and do this, you come back to the same place. Then you go and do a fourth time. You go and do, you come back to the same place. So you keep doing so long as the thing is true. You only stop when the thing is what? False. But when it is true, you keep doing or repeating. Okay? So please take note of that as well. Now, all this talk of repeats, true or false, and the rest, I want to just remind you that when we're doing our operators, okay, when we're doing our exposure to operators, we discussed that arithmetic operators are not the only operators. That in programming, you can have what we call relational and logical operators as well. Okay, so everybody remembers the equal to operator. Okay, so in programming, we have an operator called the equal to. It means that we check whether maybe two things are the same. If they are the same, we return a true. But if, for example, 9 is not equal to 13, then we return a false. Okay, so we return a true if the two things are the same, and return a false if the two things are not the same. Then in programming, if you want to test whether something is not equal to the other, we use what we call the not equal to operator. In most programming languages, we'll check whether 9 is exclamation equal to. This operator is called not equal to. Okay, so for example, over here, 9 is not equal to 9 is false because 9 is equal to 9. Okay, so if we write 9 is not equal to maybe 10, this one is rather true. It's true because 9 is not equal to 10. But this is false because 9 is equal to 9. And you are saying 9 is not equal to 9. I hope you understand the general idea. We call it not equal to. We use the exclamation and equal to operator. Please don't put spaces in between them. Okay. Okay, there was a question by Mr. Otabel. He says what? Sir, does it mean we only use two shapes in showing the relationship in the repetition? Okay, you are talking about, sorry, you are talking about, oh, it's not moving. Okay. Are you talking about the shapes over here for the flow chart?
Yes.
Oh, no. Oh, come on. But we already discussed this thing long time ago. Okay, the shapes are just there for demonstration purposes. Okay, if we start to write actual programs, we will use the shape that is meant for the particular line of the program. This is just to, of course, I can't put all the shapes in there simply because I'm trying to show you something. Okay, so it's just there to show you that it will look like this. Okay, but it doesn't mean that this is the only two shapes you can use. Hello?
Thank you very much.
Are you clear about that, or we still need a deeper understanding about that?
I'm okay, sir. Thank you.
Okay. Yeah. So I cannot for any example I give in the slide or example I give in class, I can't use every single scenario of the thing. Okay. So you just have to use your imagination a little bit to extend the concepts. Okay, we cannot do all the examples in class. Neither can I put every single example in the slide, but I can try and show you how things could look like so that if you are doing yours, you can also follow suit or follow same. Okay, so this one is just a demonstration I put in the slide. Okay, it's just a demonstration. It helps to explain this one. Okay, but it doesn't mean that every single example I will do, which will involve a while, will look like what you are seeing over here. It will be similar, but it will not look like that. Okay.
All right, sir.
I hope you understand me. Okay.
Yes.
Then of course, everybody knows about the less than. Okay, so for example, if we have 9 less than 10, the answer is what is true because we know 9 is less than 10. But if we have maybe, for example, 9 less than 5, we know that 9 is not less than 5, so the answer is going to be what? False. Then, of course, you notice that in your mathematics, you write less than or equal to, and then you write greater than or equal to. But unfortunately, on your computer, we cannot generate the same symbols. So instead of less than or equal to, we normally would write less than and then follow it immediately with an equal to. And then over here, in the place of greater than or equal to, we write greater than and immediately follow it with what? Equal to operator. Okay, this is more acceptable in programming. This is more acceptable in programming. Okay, so most of you already understand how these two work. So we'll proceed from there. Then in programming, if we want to connect multiple multiple relational or comparison statements, we use what we call logical statements. Okay. So how do we connect multiple relational statements? Oh, Mr. Daniel, your hand is up again. Mr. Daniel said, will this statement be true? Okay. Okay, so it will not be true. It will not be true, okay, because in programming, like I said, uppercase characters are different from lowercase characters. In fact, computers can compare characters, okay, because every character has something called an ASCII code. Okay, so I think the ASCII code for capital A is somewhat like 95 or so, and then the ASCII code for lowercase a is like 65 or so. So when it tries to compare the two things, it will be false. So your friend with the strange name is correct. Okay. Okay. Thank you. Thank you. Okay, so yeah, so I was saying if you want to combine multiple comparison statements, you use the operators. You use the operators and or and then the not. Okay, so an example for the end, if you want to combine, like for example, 9 is not equal to 6 and 5 is less than or equal to 2. Okay, what will happen is that here the answer will be false because the answer will be true, sorry, because 9 is not equal to 6. And then here the answer will be what? Will be false because 5 is greater than 2 instead of being less than or equal to 2. Now, if you have true and false, the overall answer will be what? Will be false. There's a table I can show you that describes how to evaluate the responses, okay? Then the or, what it simply does is to compare whether these two things are, either of the two things are true. If either of the two things are true, then we return a true, okay? Here, if either of the two, here we only return, here we only return a true if both of the expressions are true. So if we have true and true, then we return a true, okay? But all other situations, we return a false, okay? Then the not is used to negate something. So for example, if the response over here is true, then the not of true will become a false. If the response was false, then the not of false will become a true. So it's also called the inverter. Okay, it's used to invert a true to become a false and a false to become a true. Sorry, okay. So I have a table to demonstrate the not operator. So you have over here in the table, when the expression is, when the expression is true, it becomes a false. And then when the expression is false, it becomes what? A true, okay? Then over here, let's evaluate the expressions we see over here. So for example, 6 is less than or equal to 7. What happens is that because 6 is less than or equal to 7, the answer will be true, okay? But the not of true is equal to what? False, based on the table over here, okay? So true will become what? False, and false will become what? True. Then over here, this is greater than, A is greater than capital B is false, okay? The answer is false, okay? But the not of false is equal to what? True. Then 13 is equal to 13. The answer is what? True. But the not of true is equal to what? False. So hence you have this over here, okay? Then 10 is not equal to 89 is true, but the not of true is what? Is, oh, sorry. Okay, the not of true is false, okay? Then the and operator, like I was saying, I have a table here to describe. So if we have true and true, the answer will be what? True. If we have true and true, the answer will be what? False. If we have false and true, the answer will be what? False. If we have false and false, the answer will be what? False. So based on this table, let's evaluate the following. So 14 is greater than 7 is true, and then 24 is less than 19 is also what, I think that one is false. Yes. So based on true and false, the answer is what? False.
False.
If you look at the table, yeah. Then 12 is less than 100 is true, and then 7 is not equal to 17 is also true. So true and true, the answer is what? True. Okay, so that is how your computer will evaluate it. So that's how you as a programmer, you should also understand it going to work, okay?
Okay.
Then the last but not the least operator is the OR operator. So here we use the pipe. So true or true, the answer is what? True. And then true or false, the answer is what? True. And then false or true, the answer is what? True. And then false or false, the answer is what? False. So here the rule is that it is true when either is true. Okay, when you have a true in there, it will be true. But when you have both of them false, it will be false. Okay, so over here, let's look at this 14 greater than 7. We know that one is what is true, and then 24 less than 19. We know that one is false. But even though there's a false in there, true or sorry, it keeps moving. I don't know why it keeps moving. Oh, sorry. Okay, so true or false, the response is true because one of them is true, and then this is true, this is also true. So true, yeah, true or true, the answer is also what? True. Are we okay with the Mr. Nathaniel?
Sir, please, can you have two operational signs in one expression? Like the one with the previous. Please, can you go to the previous slide? Yes, so the second expression, 12 is greater than 100, and
Yes.
not before the bracket 7 greater or less than 7. Greater or equal to 70.
Okay. I don't understand.
So right after the end, can we have a not sign before the bracket?
Yeah. So if there's a not in front of this one, so what it means that you have to turn this one to a false. Okay, so the answer will no longer be true, but the answer will be false, because based on the table, if you have true and false, your response is what? False.
All right.
You can have that.
Yes, sir.
Okay. There's a gentleman. Is that a gentleman or a lady? Is it? Okay, Baba. Sorry, Baba. Let me finish with this, and then I'll take a look at that one for you. Okay. Unfortunately, I don't know how to get it to this machine, but I'll take a look at that one for you. Okay. Okay. So let's push ahead. Now let's pick up selection control statements. So you were telling me you don't understand really well. So I'm going to pick it up, and then we're going to dissect it and look at what type of statements fits into the selection control statements, and how we can also write selection control statements. Okay. I think your assignment, which you have to submit at the end of the face-to-face the next time, has an example or has a question that is a selection control statement. Okay. So let's look at it critically. Now, so selection control statements are statements which specify a block of code to execute when a particular condition or test is true. So there will be a test, and then when the test is true, we run a particular block. Now, there are 3 ways to construct selection control statements. We have what we call the single alternative, we have the dual alternative, we have the multiple alternative. The single alternative is sometimes called the one-way selection, or it's also called the if statement. And then the dual alternative is called the two-way selection, or if-else statement. And then the multiple alternative is also sometimes called the if-else-if statement. So let's start with the very simple one, which is the, before then, let's look at the, so this is what I was drawing for you probably earlier on the whiteboard that some of us were not understanding. But basically, it's very easy. There will be a test. There will be a test. And then if the test is true, we go and do the statements in the statements over here. And then we exit the loop. Sorry, we exit the selection. Then here to do our alternative, there will be a test. If the test is true, we go and do this one. And then we go out of the test. But if it is not true, we go and do this one, and then we go out of the check. Then the if-else, if we can have multiple of these littered all over the place, depending on which one, or the first one, which is true, we go and run only that code, and then we run out of it. So even though there are many checks, we only do up to the point where the value or the test is true, and then we run out. So let's start with a very simple one, the single alternative one-way selection statement, okay? So the simplest type of selection statement is what we call the single alternative statement. Most programming languages refer to it as the if statement. So I have the rules for the if statement. Now, for the if statement, if the condition is true, we go and run all the statements. But if the condition is not true, which is what false, we don't run any of the statements. So it looks simply something like this, okay? So if you can see from here, we ask the question. If it is true, we go and run this one, and then we go out, okay? But if it is not true, then we go out, and then we don't pass or we don't go anywhere else, okay? The syntax for the if statement looks something like this, where we have an if, and then you have a condition. The condition can be useful to build with any of the operators, right? Greater than or less than, okay? Not equal to, and equal to, okay? We have the ampersand, we have the pipe, and then we have the not, okay? So you use these things to build the condition. Then if the condition is true, we run all of the statements down here. All of these statements are run when the condition is true. Are we okay? Okay.
Yes, sir. Yes, sir.
Okay, that's good. Let's look at some simple examples. Okay. So simple example. Number one. So in this first example, number one, we are checking whether age variable. Is greater than 18. If the age variable is greater than 18, we want the computer to write eligible to vote. Are we okay? So for example, if the age variable contains the number 12, what's going to happen is that when we run or when we test whether 12 is greater than 18, the response will be what? Will be false, because 12 is not greater than 18. And so we don't do any of the statements inside the if statement block. Are we okay?
Sir.
Yes, sir.
Does that mean, for that example,
Yes.
18 years is not this one will give you a feedback that not eligible?
No, nothing. There will be no feedback. There will be nothing.
Okay, so from there, that one 18, there will be nothing.
What is 18? What is 18? Are you talking about the 12 or the 18 we are checking the 12 against?
So I'm asking if we input 18.
Look at the variable. The variable age contains the number 12. So that's what you should look at, not the 18 we are checking against.
I am comparing it with the sign, greater than sign.
Yes, but 12 is not greater than 18.
So I'm asking if we use just greater than.
No. Let's look at this example. Don't go off. Look at this example, and then do you understand that 12 is not greater than 18? And so because 12 is not greater than 18, nothing will run?
Yes.
Okay. That's very good. You should understand this example before you take your class to somewhere they don't understand. Okay. So in this example, we agree that oh no, what did I do? We agree that age contains the number 12. Please give me a minute. Yeah, it's on. Oh, it's on. Okay, sorry. So in this example, age contains the number 12. And because 12 is not greater than 18, the response from the test is what? Is false. Okay. So because the response from the test is false, this one will not run. Nothing will run. Okay, but if, for example, age contains the number, if, for example, age contains the number 25, and 25 we all know is greater than 18, that will be what? Will be true. And because that is true, this, okay. Because that is true, this one will run. Okay, do you understand it now?
Yes.
Okay, so it will only run if the test is true. So always look at the test. It's very important you focus on the test. That's the part of the code that is most important. The test. Sorry. Yes. Good morning. Hello. Oh, me, I think I create, and I won't war around. Me know.
Please, your mic is muted.
I think it's phone call.
Yeah, I thought it's
Phone call.
Oh, okay. Hello.
Yes,
Hello.
sir. Yes, sir.
I'm not muted. Okay, I'm not muted. I think I unintentionally touched it. Sorry. Can you hear me now?
Yes, sir.
Okay. Okay. So, for example, over here, the most important thing is to check the balance against the amount. So, for example, your Momo. Let's say your Momo balance is 100 cedis. Your Momo balance is 100 cedis. And you want to withdraw 200 Ghana cedis. Will Momo allow you to withdraw the 200 Ghana cedis?
No, sir.
Aha. So you see that we are doing a check. The check is checking whether balance is greater than the amount you want to withdraw. If balance is greater than the amount, then we allow you to withdraw. Okay? But if, for example, your balance is 100 Ghana cedis, you want to withdraw 50 Ghana cedis. Notice that balance is greater than the amount, and so this is what? It's true. And once it is true, we should allow you to withdraw the 50 Ghana cedis from your balance, and now your balance will be what? 50 Ghana cedis, because we have allowed you to withdraw. Are you understanding the intricacies?
Yes, sir.
Okay. Those of you who are saying they don't understand, it's very simple. Just ask your question, okay? I will answer your question, but don't keep it to yourself, okay? But focus on what we are doing. Don't be imagining too many things, and don't go on all the way to exams. You've not understood what is currently being done today. So try and understand today before you veer towards exams. Yes, Mr. Nathaniel.
Yes. My earlier question.
What is your earlier question?
The age. I'm asking if
Okay.
because of the greater than sign over there.
Yes, of course.
I'm asking if the age is 18. Will it be a true or a false?
So sorry. Okay, hold on. Okay, so check this. So is 18 greater than 18? Is it true or false? You should always check it yourself. Is it true or false? Or you don't know? Okay, so you see that the key thing is understanding that simple mathematics thing over there. Is very different. That's what most people struggle with. Okay, it looks like a primary school mathematics, but you see that you are even confused yourself. Okay, so 18 is not greater than 18. 18 is equal to 18. If it had been 18 is greater than or equal to 18, then this will be what? Will be true. Okay, but this is false. This is false. Okay, and then 18 is less than 18 is also false because 18 is not less than 18. Okay.
Okay.
So it's just the greater than or less than.
Yeah. So in this instance, if maybe you are checking for you have created something for Ghanaians, then those people who are of age of 18, they won't be eligible to vote.
No, you should write it so that 18 people can. You can write it so that 18 people can vote.
Okay, so it should be like age equals greater than age.
No.
Greater
Age
than or equal to
greater
18.
than or equal to. Yes, I just wrote it for you. I don't know if
All
you
right.
remember. I just wrote it.
Yeah, I saw it, sir. Thank you.
Okay. Mr. Theophilus.
All right, sir.
Yes,
so, check balance. So, if greater than or equals to amount,
Yes.
if balance greater than or equal to amount.
Yes.
So, say if I have a system, let's say I have a Momo platform, and I want, let's say, if somebody has 100 cedis in the amount, the person should have at least a minimum of 1 cedis left in the amount.
So you can add more. You can add more conditions. For now, you are learning. That's why I'm just doing simple. Okay. But you can, in fact, like I was saying, we are trying to help you to understand it for now. Okay. In the future, you will learn actual C++ programming and the rest. And you see that you can add more. But even today, even now, we can add more. But for now, you are just starting. So I can't be adding those things. I want to make it as simple as possible so nobody gets confused. Okay.
Okay, sir.
But you can add a condition for checking the minimum balance. You can add a condition for checking whether they have reached their maximum withdrawal amount. You can add multiple conditions.
Okay,
the limit to the things you can add is your mathematical ability. Okay. So the mathematics is what really will prevent you from adding those things. If you don't understand how the mathematics works in that regard, it will be difficult to imagine it and then code or write the program in that manner.
Okay.
Thank you.
Mr. Felix.
Good morning.
Yes, morning, sir.
Yeah, so means this particular process, before you run it, you have to initially check if what you are putting it is actually true before you do your process, right?
You have to understand when it can be true and when it can be false. I know how. Press down. Yeah. So you have to know when it can be true and when because you are never going to be with the user. Okay, the user is going to be somewhere using your program. You can't go and stand by them and check what every number they will enter. Okay, so what you can do. Press down. So what you can do is to be able to check when something can be true and when something can be false. Okay, so that if it is working wrongly, so that if it is working wrongly, you know when it is working wrongly. Okay, you need to know when it is working wrongly and when it is working correctly.
Okay, yeah, I understand.
So because, for example, if you want to know that a user will always enter, or the system will always allow the user to only withdraw the amount of money they have in their balance, then you should know how to write it so that the mathematics over there will be correct. Okay, but if you write it and then the user can withdraw more than their balance, it means they will be stealing from the bank or they will be stealing from you.
Yeah.
Yes, so you should know when it is true and when it is not true. But as for what the user enters, you cannot stop the user from entering anything they want to enter.
Right.
Okay, so look at this example, other example too as well. So what it means is that if score contains the number, let's say 79, notice that because 79 is less than 90, you will not get grade A. You will not get anything Okay, but if, for example, score contains the number, I don't know why it keeps going back. I think I'm running out of battery, I think. Okay, but if score contains the number maybe 100, then you are definitely going to see grade A. What? You are definitely going to see grade A being printed, okay? Is it understood? Is it understood?
Yes, sir. Yes, sir.
Okay. Here too, we are checking whether a number is negative. You know, negative number is what? Less than 0. Positive number is greater than 0. Okay? So if you want to check whether a number is negative, then it means the number has to be less than 0. So any number, so if, for example, you put 5 over here, because 5 is not less than 0, this code will not run. Okay? But if, for example, you put the number -5, because -5 is less than 0, then this code will run. Are we okay?
Yes, sir.
Okay,
Yes, sir.
that's good. Okay. we are getting there small. Then we can have the dual alternative. So a dual alternative is also called the two-way selection statement. Emmanuel says that Vim is not inside the yes, sir. It will be well, okay, Emmanuel, it will be well. We can also have the dual or the two-way selection statement. This one is also very simple. So someone will ask me a question. So say, do we only do something when it is true? What if the thing we want to do is not true? Okay, so the dual alternative selection statement takes care of that. The situation where the thing we want to do one thing when it is true and another thing when it is what? False. Okay, so in that case, you will go in for what we call the two-way selection statement or the dual. Sometimes we even call it the if-else. Okay, the if-else selection statement. Very, very, very simple selection statement. Okay, so the mechanism is that if the test condition is true, we do the first block and then we exit. But if the test condition is false, we don't do the first one. We rather come and do the second one and then we exit. Okay, so we have two blocks. The first block, second block. We only do the first one if it is true, or we only do the second one if it is what? True. But we cannot do both. We only do one. So it can either be true or be false. Oh, the slides are on the LMS. My dear friend, you have not checked the LMS for a long time. Hakim, you have not checked the LMS. Hakim, please check the LMS. There are assignments and homework and things on the LMS too. Okay, check it. Okay, so let's look at the syntax. So that syntax is very simple. We first write the if, we write the condition, we want to check whether it is true or false. Then we write our statements for true. These statements are only run when it is true. Then else, we go and write this one, and then we run these statements. So these other statements are only run when it is false. Are we okay?
Yes.
So the next examples you are going to see, you will see an additional layer. Okay? The additional layer is the else. And then to be followed by other statements. Okay, the else is only run when the statements up here are false. Okay, so let's look at this example. In this example, we are checking if hours is greater than 40.0. If the hours is greater than 40.0, then we calculate overtime. Overtime is equal to what? the 40 times the rate times the overtime hours. Okay, so this is how to calculate it. Okay, don't worry about the calculation. The most important thing is to understand that if this one is not true, okay, then we go and do the false. Okay, so understand that if you want to specify that something is true, do something, or if it is not true, do something else, then you go and you use the if else statement. Okay, I have exemplified it in the, or illustrated it in the flow chart below. You can see over here, we are checking the condition in the kite. If the condition is true, we pass here. We come and do the overtime pay, and then we end the program. But if it is not true, we pass here, come and do the regular pay, and then we end the program. Okay? Any questions? Any questions?
Sir,
Yes, sir.
please, can you go over the previous slide, please, before coming here?
The syntax?
Yeah, no, the one before the distance, the where we were right now.
This?
Yes, sir.
Oh, but it's the same thing I explained in the, it's just, I'm saying that the mechanism of how it works is that if it is true, we go and do the green one. If it is false, we go and do the red one. That's basically the mechanism. Crystal. Chinese, no, why? But com skills. Okay. Is it understood?
Yes, sir.
Yes, sir.
Okay.
Yeah, that's the same thing I'm explaining in the example. So because of time and the rest, if I've explained it, I don't want to. And of course, I cannot remember everything I have said earlier, so I don't have it written down anywhere else. So I just want to just follow the example. Perhaps maybe the example will help you to understand it better, okay, and not necessarily go over the entire thing again. Okay. Okay. So in this example, let me explain with this example because I think the examples are better at explaining them. So in this example, we are checking whether the hours, like I said, in the if-else statement, we have two options. We do one option when the thing is true and another option when the thing is false. Okay. So we will first, like every other if statement, we'll first need to check the condition. This is called the condition. Okay. So the condition can be true or false. Okay. Now, if the condition is true, like we see over here, if the condition is true, we come and do the first statement and we stop. Okay. After doing the first statement, oh, I don't know why this thing keeps coming back. Okay. Okay. So after doing the first statement, we stop and then we go out. Okay. If it is true, if this is true, we stop and we go out. Okay. But if the first statement is not true, okay, what happens is that we don't do this one, but we come and do the second one because we only do this one if it is what? We only come and do the second one if it is false, and then we stop and go out. Okay. So that's how the if-else statement works. Two branches. We do one when it is true, one when it is false. So let's do an example. Let me check an example of whether you are following along. Okay. So an example, let me check if hours is equal to 38. Will it be true or false? Will this be true or false? Hello, if hours is equal to 38, will this be true or false? False. So because it's false. Okay, so because it's false, which one of the two will be done? Will it be statement 1 or statement 2?
Statement 2, sir.
Statement 2. Hey, who's saying 1? Hey.
Abochi said one.
Statement 2. Okay, so statement 2 will be done because when this is 38, this becomes false. Okay? Please take note. Okay? And when ours is maybe 41, is it true or false?
True.
Yes, sir.
True. Okay? So if it is true, then it means statement 1 will be done. Okay?
Yes.
Yes, sir.
So please take note of the differences in how it works. Only one will run at a time. Okay, so now let's continue. Let's continue the examination. Okay, so we can see more examples. So in this example, this is a test. This example, this is a test. This example, this is a test. Now look at this first. Let's get example number 1. So in example number 1, this is a true part. Okay, and then I'll use a red for the false. Okay. So we are checking, is the amount greater than 0? If the amount is greater than 0, then we are doing only the first part, okay? But if the amount is less than 0, then we are doing the second part. Are we okay?
Yes.
Okay. Then second example, example 2, okay? In example 2, we are checking if the score is greater than or equal to 90. If it is greater or equal to 90, we do statement 1. But if it is less than or if it is not equal to or greater than 90, we do what? Statement 2. So we'll only do one of the two, depending on whether it is true or false. Then in the last or the third example, we are checking if your age is greater than or equal to 18. So you see, I rewrote the whole thing, but this time around, I wrote it as greater than or equal to 18. So if your age is greater than or equal to 18, you will see eligible to vote. But if your age is not greater than or equal to 18, you will see not eligible to vote. Are you okay?
Yes, sir.
Are more of us understanding it now?
Sure.
Yes, sir.
Yes, sir.
Any questions? Any questions so far?
No, sir. No, sir.
Okay, Osei Solomon has a question.
Yes, sir. Good morning.
Morning, sir.
Sir, please, would there be a case that you'll be asked to find if and again the true statement and the false statement? Is there any situation that you
calm down. I don't understand what you mean. Calm down, explain to me very well. Okay.
Okay, so sir, what I mean is, would there be in a situation whereby you'll be asked to find the true statement, and again and
what do you mean by you'll be asked to find the true statement? I don't get that. There'll usually be maybe a scenario, and then you will deduce from the scenario what the test should be, and then you will write what should be true and what should be false. But I don't understand what you mean by what do you mean? Do you have an example in mind, or you have seen something like that, or I don't know?
Sir, please, on the previous slide.
Okay. There's an example like that.
I want your hand. Yes, with this one.
Yes.
With this one.
Yeah. Please, can I come in?
No, let him finish. Let him finish. I'll answer your question, but let him finish his question.
Yes, with this one, if it is the true statement, that's the yes one. That
Yes.
you said we should draw only, if it is true statement, we should draw only the green part. But if it is false statement or no statement, we should draw only the red part. Will there be a case that you'll be asked to say draw this one, the true statement and the false statement? Or you'll be asked to find only the
I have not spoken about drawing. I have not spoken about drawing. So I'm surprised you heard that from me. I have not spoken about drawing anything. I have drawn and colored it just so that you can understand which one is run, but I have not spoken about drawing. For if you have to depict the thing in flowchart, you should depict the whole thing in flowchart. You cannot maybe illustrate one part and leave the other part. It will be incomplete.
Okay.
So, and I don't think when you even illustrated it in flowchart, you can even color it. It would be too. You cannot color it. I've colored it so that you can differentiate between which one is true and which one is false. Okay, but
All right.
I don't recall telling you to illustrate or to draw only the true part and leave the false part or something. You should draw what is your best interpretation of the entire code.
All right, sir. All right, sir.
Yes, you will be asked to illustrate. So you should illustrate what you think is the best interpretation, but you cannot illustrate one part and leave the other. It will be totally incomplete.
Okay, sir.
Okay. So Eric is saying, can we say that in an if-else statement, you are required to do the illustration for the yes or no? You mean the flow chart? Eric Arno, do you mean the flow chart? Oh, I'm only doing it to help you understand. Okay. I don't know why or how you people are seeing the whole thing, but I go the extra mile to let you understand. Okay. It does not mean that, for example, if I ask you to illustrate in flowchart, can I help? Okay. You can talk. You can open your microphone and talk.
Yeah. Sir, please, good morning.
Yes, please make it snappy.
So
The time is already fast spent.
with this scenario, assuming you are sending money from Telecel to another Telecel number,
yeah,
it will be direct. But when you are sending Telecel to MTN, there will be an option there that you should select other network. That's between the yes and no on the days.
I don't get you very well. What do you mean by, so you are comparing the Telecel send of money to like an if-else statement?
Yes, please.
Well, I don't know if that's what is working behind the scene over there. Okay, there could be lots of different things we can use to make that work over there. Okay, so just come down to basic example. Nobody's going to ask you to write up a code for Telecel. So come down to basic example. Try and understand the basic one. If we can build on the basic one, can you follow with the basic one, and then let's build on the basic one, and then let's move up step by step. Some of you are hyper imaginative.
So can we use the age one, the eligible to vote?
Yeah. Eligible to, why not? So yeah, why not?
Yeah.
Okay.
So an example will be if the test is age is greater or equal to 18. So if someone keys in an age which is less than 18, then it will go forward to process it and bring not eligible to vote. But in the earlier one, the one step one, that one, it will not process the
anything.
If the else.
Yes. Thank you. So that is basically what I want you guys to see. In the single if statement, nothing happens if the statement is false or if the test is false. But in the dual if statements, when it is true, something happens. The first one happens. When it is false, the second one happens. Okay, so over here, you can see that if your age is greater than 18, you will be eligible to vote. But if your age is less than 18, you will not be eligible to vote. Do you guys see that?
Yeah. Yes, sir.
Yes.
Okay. Yes. Okay, so let's build on this step by step. Okay, this is simple. So let's look at the simple ones, and then we build from there. Okay, step by step. Okay. Sorry again, I touched something. Okay. Now, even with the simple, you see, the gentleman was asking about the tail cell thing, and I didn't want you guys to walk all the way into that pit. Okay. Now, if, for example, you have a situation where you want to check multiple things, okay, you want to check multiple things. And currently we have learned only two types of if statements, the single if and the dual if statement, okay? But you want to check multiple things. You don't know how to do a check for multiple things, then you can use something we call the nested if statement. This simply means putting an if statement inside another if statement. It's very simple. It's not very complicated. The same idea. Now look at the example on the right. So you can see in this example, we have a bigger if statement, okay? In this if statement, we are checking if the balance is greater than 5,000. If your balance is greater than 5,000, we set your lending rate at 7%. But if your balance is not greater than 5,000, then look inside the false part, okay? In the false part, we have another if statement where we are checking whether your balance is greater than or equal to 2,500. If it is, we are setting your lending rate at what? 5%. But if it is not, then we go to the false part where we have another if statement. Then we are checking if your balance is greater than or equal to 1,000. If it is, then we are setting your lending rate at 3%. Else, we will set your lending rate at 0%. So what it means is that if I come to this program with a balance of, let's say, 7,500, which one of the 3 or 4 lending rates will I see? Will I see 7? Will I see 5%? Or will I see 3% or 0%?
7%.
7%.
7%. 7 because 7,500 is greater than 5,000. So the first instance, this one will run. Are we okay?
Yes, sir.
That's very good. Okay. Let's do another example. So for example, if I come and I say my balance is 850 Ghana cedis. Remember, 850 is not greater than 5,000. So you go to the false. Okay. 850 is not greater than 2,500. So you go to the false. 850 is not greater than 1,000. So you go to the false. And so my lending rate is what? 0%. Yes. So in programming, you can do nested statements or nested if statement. You can put an if else statement or an if statement inside another if else statement. Usually we use if else statements. Okay. So the gentleman's question about the Telcel and Ghana mobile MTN mobile money and whatever. Okay, we can actually wrap our mind or we can actually wrap our mind around it in this manner. Are we okay? Any questions? Any confusion? Hello?
No, sir.
Abdul Sani. Abdullah, sorry, Sani.
Please, can you go over it again?
Go over what?
The nested selection statement.
Oh, my dear friend. Okay, so here we are doing a check on balance. If the balance is greater than 5,000, you do the first one. If it is not, you go to the else part. In the else part, we have an if statement also. If the balance is greater than 2,500, you do the first one. If not, you go to the else part. Inside the else part, there's also an if-else statement. If the balance is greater than 1,000, you do the first one. If not, you go and do the else part. In here, we have another rate over, and you can keep putting if else, if else, if else, as many of them as you want to put over here. Okay. Let's look at another example. So in this other example, look carefully. We have an if-else block. Okay. You can see the if and you can see the end of the if. Then look inside the true part. We have an if-else statement inside the true part. So this one is done when the temperature is greater than or equal to 50. Okay. Now, the else part is very simple. You can see it is only one statement, okay? I just only wanted to show you that it's not always you have to put it at the false part. You can also put it inside the true part, okay? Now, look inside the true part. It's an if statement also, okay? Then in here, we have the true, and then we have the false, okay? So here, we will first check, is the temperature greater than or equal to 50? If it is it greater than or equal to 80? If it is, then you go good day for swimming. But if it is not, it means it is still above 50, but it is not up to 80. Okay? So you say good day for golfing. Are we okay? Hello?
Yes, sir.
Am I still on the call?
Yes.
Yes, sir.
Yes, sir.
The one inside is called the inner if. The one outside is called the outer if. Okay? So we just give them these names, but basically they are not much. Okay? So you can put an if statement inside an if-else statement. An if-else statement inside an if-else statement. You can put another one inside. In fact, each of the branches or each of the arms, you can put more statements inside. Okay. Then the final type of if-else statement is called multiple alternative statements. Most programming languages call it if-else-if statements. It comes about because sometimes you want to test multiple things at the same time. You want to test whether something is true or other thing is true or the other thing is true or you see, so that kind of thing. Okay, so if you want to do that, then you go in for the if-else-if statement. I have the syntax on the left and an example of the flow chart on the right. You don't have to do both, okay? You can just do one or whatever the question is asking you, but I'm just trying to show you how it looks like. Some people are good at pictures, okay? That's why I use the flow chart. Some people are also good at understanding the words. That's why the pseudocode is there, okay? So in the syntax, this is how you write it. You start with an if condition, and then you write your statements if the first one is true. Then you do else, and then you immediately follow it with what? If condition again. This time, the two conditions are different because this one is only applying to the first one, and while the second one is applying to the second one. This one only applies to the second one, okay? Whilst this one only applies to the first one. Remember, you will only see any of this if this is true. And you will only see any of this if this is also true. You can write as many of them as you want. When you are done, you can optionally add an else statement. The else statement is just like the false. So if none of these conditions are true, then the false will run. Okay, so let's see an example. So here we have two examples. In the first example, we have score equal to 5. Then we check, is score equal to 10? We know score is not equal to 10, so we don't run this one. Then we check, is score equal to 8 or equal to 9? We know it's not equal to 8 and 9, so we don't run this one. Then we check is score equal to 6 or equal to 5. We know it is not true, so we don't run this one also. But we check is score greater than or equal to 1 and less than or equal to 5. Yes, we know it is, so we write what? The rating as what? D. So notice that none of these are run, only the last one is run. And over here too, there is no else statement. There's else if, and if, but there's no else statement. So we only run the one that was true. Okay? Another example, balance is 1,000. Now, if balance is 1,000, now if balance is greater than 5,000, then interest rate 7. Else, if balance is greater than 2,005, interest rate 5%. Else, if balance is greater than what? 1,000, interest rate 3%. Else, here, interest rate 0%. Now, if a balance is 1,000, then we know that this one is false, this is false, but this is true. So we get interest rate at what? 0.303%. Okay? Sorry, 0.03 or 3%. Okay. Any questions? This one is very simple as well. Okay. So you can see that it's very simple. It's very laid out, very flat as well. Okay, another example. I think this is the last but not the least example. So you can see over here, we are checking, we create a variable called month. Remember, month is an integer variable. So it means we are expecting a number, okay? So you enter the month number. So we can enter 1, can enter 2, can enter all the way to what, 12. So depending on the number you enter, we are checking the month and checking the number, and then we are printing the name of the month, okay? So over here, for example, if the user entered the month as month 7, okay? So we check, is month equal to 1? Is 7 equal to 1? Okay, we check, is 7 equal to 1? No, that's false. Is 7 equal to what? 2? That is also false. Is 7 equal to what? 3? That's also false. Is 7 equal to 4? That's also false. Is 7 equal to 6? That's also false. But 7 is equal to 7. So this is true. So we print July. Are you with me?
Yes, sir.
Yes, sir.
Okay.
Yes,
So you
sir.
understand the strategy, okay? For example, as well, if the month we entered is March, then obviously, after testing whether 3 is equal to 3, we will print the month of what? March. If the month we entered is maybe the month 12, then after checking everything, when we, okay, there's no, you should notice that there's 6, there's 7, there's 8, there's 9, but there's 10, but there's no 12. So it means that we will see not acceptable. I didn't add the 11 and the 12 because of space. Okay, so because if you enter 12 and currently there's no print statement for 12, you will go and do the else, and then you see not accepted. Yes. So any questions? And then we close out our class. Yes, sir.
Sir, good morning.
Morning.
So please, I have 3 questions.
Please ask your questions.
So please, can you write loop inside each statement?
Oh, we've not done loops yet. And then we do. Yes, you can write loops inside. Okay.
You mentioned loop earlier on. That's what I'm asking.
Yeah, your line is breaking up.
Yes, earlier on you treated while loop. That's what I'm asking. Whether you can write loop statement inside.
We didn't treat while. I just mentioned that loop is also a construct, but I've not explained it well. Okay. I will take my time and explain it very well. Okay.
All right.
Question 1.
Since that one has not been this I cannot continue again. Maybe next week when it's
okay. Thank you. Theophilus, Mr. Theophilus.
Okay, sir. Thank you. So, sir, is it possible to, if declare the month as an integer, then the three right enter the month number? Is it possible to, if you want to take 2 months at the same time?
Oh, it's only going to accept 1. Okay, 1. That's 1. Hello.
Yes, sir.
Hello. Yes, it's only going to accept 1 for now because it's just 1 integer. You create 1 integer, 1 number. If you want to collect 2, you have to create 2 integers.
Okay, sir. All right.
Yeah.
Thank you.
Who is 25, 26, 10, 40, 104? Any other question? Hello?
No
okay,
questions, sir.
So in the absence of any further questions, okay, last minute, Khadija. Madam Khadija.
Good morning. Good
Hello.
morning.
Morning.
Yeah, good morning. Please, can a correct example of this be, let's say when you are opening your phone or when you are putting, what's the name? I don't know. You see, when you open iPhone for the first time, they ask you to put in your name followed by your date of birth stuff. Most times, you are going to be asked to, let's say maybe in the year, instead of the writing, then you put in, what's the name, numbers, right? So can this be a correct example? Let's say 1999. Sorry, 1991, right? Then when you put in, instead of the letters that will come, is number rather. So that's maybe if
Madam
199,
Khadija.
then this year, yeah.
Okay, so this is just an example to demonstrate if statements. Okay, so it's not really, I understand what you are trying to, but it's too high. That one is too way off when you start to do graphical user interfaces and then you try to understand what is happening in there. That's way off from here. Okay, it's very far away from here. Here we are trying to make you understand the basic building blocks. So come to the basic building block. The basic building blocks is if statement, if else statement, if else if statement. Don't mix it up with dates and those things. Okay. You will not see any program construct with just if statements in there. There will be lots of things happening in the background. Okay, if it's one of the things, whenever your program or your computer is doing a checking whether something is true or false, it may be doing if else or if something. Okay, so that's what I have taught today.
All right.
And I want you to understand for that, for what it is, an if statement. Okay.
Okay, thank you.
Yeah, you're welcome. Maybe give it a few days, learn, re-watch the video, go through the slides, go through some of the tutorials or stuff. You should understand. Some of you have a lot of, I can see that maybe some people with some advanced level understanding of this, and they are in a hurry to get us all the way to where their level is. But we need everybody to follow along this course. Okay, it's an academic course, so I will try to make it understandable for everybody, even the people who are now learning for the first time. Okay. Any other questions? If there are no other questions, then we will call it a day. And then I think next week is a holiday. Okay, so please go through the material. There'll be asynchronous lectures and lectures following after the holidays. Okay, there's an assignment, form groups, and then complete the assignment, and we'll submit in person when we meet on campus. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Hello, sir.
Yes.
Please, the assignment, is it the one that we are supposed to form groups of 2?
Yes, please.
Okay, sir. Thank you, sir.
You're welcome.
Thank you, sir.
On behalf of the class, I'd like to say a big thank you.
Thank you.
Enjoy your lectures.
Thank you.
Please, we are using the same link for the next class.
Thank you, madam.
Yeah, please. I want to confirm if I'm hello, Sam. Please, I want to confirm if I'm looking at the right assignment. Is it the one with unit 5 group assignment?